Hi everyone. In this video, let's talk about the noisy neighbor problem. So imagine that you are in your room and you are watching Netflix, you are watching Stranger Things in Netflix and you are really enjoying the show. Now everything is going good and your little brother is in your next room and he is playing online games. Now everything is going good. Now all of a sudden you see that the video quality has degraded and in Netflix you are seeing a lot of buffering. And at the same time, your father, who was also watching YouTube, he also complains that the videos are not loading for him. Now you check the Wi-Fi and network connection, everything looks good, still the videos are not loading. So upon checking, it turns out that it was your little brother who was downloading a 500 GB file, and that has caused all the people who are connected in the same Wi-Fi throttle their speed. I'm pretty sure that you have definitely faced this kind of scenario or this problem in your home. So this problem, we call it as a noisy neighbor problem. So where multiple people are using the same resource, and if one of them starts to do some heavy operation and that causes them to use that resource more, and that way the other people who are also using the same resource, they face the problem, their performance is not good. So here I have just very simple diagram to elaborate the scenario. So you are watching YouTube and your brother was playing some online games. Now all of a sudden you can see the videos are not loading anymore for you, and it turns out that your brother is now downloading a 100 GB game, and that's the reason the internet speed got reduced for all the people who are using the same network. So this is what we call as a noisy neighbor problem. Now we have another diagram to explain the problem in the form of the apartment analogy. So suppose that you live in an apartment, right? This is your apartment, and in the same building there are other apartments as well. Now in that same building, some of the resources are shared. That means the electricity or the water tank. So whatever apartments are there in the same building, they all use the same electricity board, they all use the same water tank, right? And all of a sudden one of the apartment person, they started to consume more water. Suppose they ran 10 washing machines altogether, okay, which is consuming more electricity and it is also consuming more water. And due to this person, what happened is that for the rest of the people, whenever they are trying to run any electric appliances, they are seeing low voltages and they are also seeing that the water pressure is low at their washroom. So the reason is this person is using more resource, more electricity and water, and that has resulted in all the apartments in that building, they are now facing the problem. They are not able to use the resource properly. And this is exactly what we call it as a noisy neighbor problem. Now this same kind of mechanism, this same problem applies to the cloud environment as well. So let me explain that. So here I have a very simple diagram to explain how does a multi-tenant cloud architecture looks like. So this is your cloud provider, it could be AWS or Azure. So what they do is that they have a physical server. Actually they have a bunch of physical servers, but let's assume that they have a single physical server. Now multiple companies wants to run virtual machines. The cloud provider doesn't provide the single server to each of the customer. Instead what they do is that they take a big server, they run hypervisor on top of that server, which helps it to create more virtual server from the single physical server. So what cloud providers do is that they don't give each customer an entire server. Instead what they do, they take a single powerful large server and they install hypervisor on top of that server, and that hypervisor, it creates multiple virtual machines out of these single physical servers. Now that multiple virtual machines has been created, now we can sell that multiple virtual machines to multiple companies. So you can see from the single server we have created 4 virtual machines, and these virtual machines can be used by multiple companies. Separate companies are using this. So this is what a multi-tenant architecture looks like, where inside a single server you have the data for multiple customers or multiple tenants. I have already made a video about multi-tenant cloud architecture. I'll link the video in the I button, you can check that. So this is how the virtualization works. So hypervisor creates multiple virtual machines from a single server. So the job of the hypervisor is to slice up one single physical machines into multiple isolated VM, and each of the VM, they believe that it's their own dedicated CPU, memory, disk, but under the hood they are all fighting for the same physical resources that the hypervisor has allocated them. This is the core of the cloud architecture, and that's the one of the most fundamental concept of the cloud architecture, and that's how cloud companies can reduce the cost, because they can break down a large physical server into multiple virtual machines through the virtualization, and that's how they are able to reduce the cost. The original problem that we were discussing earlier was the noisy neighbor problem. That happens mostly on the cloud which are using the multi-tenant cloud architecture. So the problem that happens is that suppose we have 4 virtual machines, right? Now imagine that all of a sudden this virtual machine, this VM2, it's doing a lot of database query, it's running lots of long running database query, or it is writing a lot of database logs, okay, or it's running some long running batch job. The problem it will happen is that all of these 4 servers are sharing the same resource. Now if one of the VM, if this virtual machine starts to use lot more resources, that means majority of the resource of this server will go to this VM2 and the rest of the VM, they will not get that much resource, that and their performance will go down. So this is the problem that happens in the multi-tenant cloud architecture. If one of the tenants starts to use more resource than they are expected to, then the other tenants who are also sharing the same physical hardware, for them the performance is compromised. So here I have a simple diagram to explain the same scenario. So we have this physical server here, and we have installed hypervisor on that server, and using that we have created multiple 3 VMs, right? Now 3 VMs are there. Now this is your VM, there are another 2 VM, VM2 and VM3. Now this VM3, suppose that it is running some long running batch jobs, it is training some AI model which requires lots of CPU and GPU and RAM. Due to this, what is happening is that majority of the resource of the server, this main server, it's going to this VM. And as a result, this VM-B and VM-A, these are affected. These are not able to function properly, and whatever the applications that are deployed on these virtual machines, these are not working properly because majority of the resources like the CPUs, RAM, network bandwidth, storage bandwidth, these are mostly used by this server. So this is the problem of the noisy neighbor problem. So this scenario, we call it as a noisy neighbor situation or noisy neighbor problem in cloud environment. This problem, this noisy neighbor problem, it's not a new problem because the cloud companies, the cloud vendors, the cloud computing companies are facing this problem from a lot of time, and over the time they have come up with some solutions using which we can mitigate this noisy neighbor problem to some extent. Okay, now let's take a look what are some of the solutions to this problem. So the first solution that they have come up with, that is known as the resource quota and limitation. So in this case, what we do is that core idea is, instead of letting the workloads use resources on a first come first serve basis, you draw a hard line in the sand for each tenant before anything runs. What we do is that we draw a hard line, we set a hard limit for all of the virtual machines for using the same resources, and we set a hard line on that. We specify that no matter what, these machines cannot consume more than this percentage of the CPU or this percentage of the RAM or storage, like that. That way you set a hard limit. So if one virtual machine demands to use more resources, it cannot do that because there is already a hard limit set on that, and it cannot exceed beyond that. And that way we can ensure that one virtual machine doesn't use too much resource, so that other virtual machines can get their fair share of usage. So how it works? So for example, in Linux there is a concept called C group, which is also known as the control groups. So this is a kernel feature that lets the operating system say that this process group gets a maximum of 2 CPU cores and 4 GB of RAM, no matter what. So even if this process demands to use more than 2 CPU cores or 4 GB RAM, it cannot use that because that is the hard limit that we have set. Similarly, in the Kubernetes, there are two properties that is known as the request and the limits. So by the request, you can specify this is the guaranteed minimum that a pod will get, and by the limit, you can set this is the hard ceiling that a pod cannot exceed. If it tries to exceed that, the CPU gets throttled, and if it is in the memory, then the pod gets killed. So in the Kubernetes, by using the request and the limit, you can set a hard limit on the quota so that one process cannot use more resources than it is expected to. Now, another mechanism that they have in place, which is known as quality of service tiers. So the idea is not all the workloads are equally important, right? So if the resources run short, then someone has to lose first, and the providers lets you define that who is that someone whom we can sacrifice. So here the idea is that you have lots of services. Now there are some of the services which are essential, which are critical. You cannot afford them to go down. For example, the payment service. So you can put those services which is very critical for the business, you can put them in the guaranteed tier. This is the guaranteed tier. So request and limit are the same for both the CPU and the memory. So these pods are last to be evicted. So these are reserved for the critical and latency sensitive services like the payment services. So these are most important services, and even if the resources you are running short of resources, so it will try to ensure that whatever service who are in the guaranteed tier, you try to allocate, you try to give your best so that these guaranteed services doesn't go down, because these are most important. Now the second tier that comes, that is the burstable tier, in which the limits are greater than the request. So these get some flexibility to use some of the extra resources if available, but can be throttled or evicted if things get tight. This tier has a little bit less priority than the guaranteed tiers. If there is a resource shortage, then we will try to ensure that these tier services, these still run. But if you are in a critical situation where there is very less resources available, then we can eventually throttle them or evict them. The third tier is the best effort. So in this tier, we put those services which are not that much critical, right? Some of the background jobs. So in this case, we do not set any request or limits. So these are the first services that is to be killed under memory pressure. This is ideal for the non-critical background jobs. So if you see that there is a resource shortage, so these are the non-important tier processes which you can afford to terminate first to free up the resources so that the above 2 tier process can run. So that was about the quality of service tier. Now the next solution that they have come up with the dedicated or isolated host. So if you just think about the noisy neighbor problem, so the root cause of this problem is that we are trying to share the resources with the multiple clients or multiple tenants. Okay, so here the idea is that if sharing of resource is the problem, then the solution is to let's just not share the resource at all. We'll not share the resource. That's the idea here. So if sharing is the whole problem, the simplest and most expensive, definitely it is the most expensive fix, is to just not share. We'll not share the resources among the tenants. AWS dedicated host and Azure dedicated host, they let you rent an entire physical server and only your VM are ever placed on it. No other customer's workload can ever land on that hardware. Give you a dedicated physical server and they ensure that only your virtual machines are running on that dedicated host that they have given. Okay, it will not be shared across any other customers, and this is very common in the regulated industries. Suppose you are handling a banking application or healthcare or government where the data security is very critical. You have to abide by different compliance rules, right? And it may require the guaranteed physical isolation, not just a logical isolation. So it might require you to keep the data or keep the servers in a specific region. So for those cases you can use the dedicated or isolated host, but keep in mind that this is the most expensive. Now the whole idea of the sharing of the resources was to reduce the cost. That was the benefit that we got by sharing resources across multiple tenants. But now that you are facing the noisy neighbor problem, so if you do not want to share the resources, if you want to go for the dedicated or isolated host, you can go for it, but that will be expensive because totally you are getting a dedicated physical machines just for yourself, so you have to pay more, so it will be expensive. But on the other hand, you will definitely get more data isolation and more data security. They have another mechanism which is known as the fair queuing for disk and network. So they have some sophisticated algorithm that in place using which they ensure that all the tenants who are sharing the same resources, they get a fair amount of usage, okay, by using some sophisticated algorithm. So one of the algorithm that they have is the token bucket or the leaky bucket algorithm. So each tenant gets their token added to their bucket as a steady rate. So each input output operation consumes a token. So if you run out of token, then you have to wait. Okay. So in this way, they are kind of maintaining a queue mechanism. So if you are maintaining like this kind of, you can say the rate limiting kind of thing, because we know that this token bucket algorithm, it can be used in rate limiting. So this is kind of a rate limiting, because if one of the virtual machines or if one of the customers are using too many resources, then we are kind of a rate limiting them, so that we are ensuring that they do not end up using more resources than they are supposed to use. This kind of rate limiting to throttle their network or their disk read output speed once they have crossed a certain amount of limit. Another mechanism that we have, that is known as the smart scheduler placement. So here the idea is that prevention is better than cure. So if you can avoid placing risky workloads next to sensitive ones in the first place, you sidestep the whole problem. So here the idea is, so the cloud provider try to identify which are some of the clients or some of the tenants which might cause a noisy neighbor problem for others. So they are trying to identify those, and once they have identified those, and they are ensuring that those tenants which have more chances of consuming more resources causing the noisy neighbor problem, they put them into dedicated instance. So for example, that there is one virtual machines where a batch job is running, that is training machine learning models, right, which consume a lot of CPU, GPU, right? And this is definitely a risky client or risky tenant rather than someone who is just serving an API. So the schedulers try to ensure that if there is some customer who has the potential to be causing the noisy neighbor problem for others, they try to group these together on a dedicated pools of hardware. So they will not probably keep these kind of risky neighbors in the shared resources. They will probably give them to some dedicated pool of hardware and mostly separate from the latency sensitive system like web applications or databases. So they will try their best that they will not keep them into the same environment or in the same environment where they are sharing the same resources with the virtual machines or with the processes of the APIs or databases, because these APIs and databases are time sensitive data, are time sensitive services, and we cannot afford to put this kind of risky neighbors along with these time latency sensitive services. So they put them into a dedicated pool of hardware. So these are some of the solutions that the cloud computing companies have come up with to handle the noisy neighbor problem over the years. So if we just summarize the thing, so what they do, and first of all, they can set a quota on the limit on the tenants, so that one tenant cannot use too much resources, and in the quality of service tiers, they prioritize the critical workloads by the guaranteed tags, so your payment service doesn't get sacrificed for someone's background job. And they have the dedicated host for the teams who need zero compromise on isolations. They have the fair queuing algorithm as well, so one single VM cannot monopolize the shared network or disk bandwidth. And they have some fair queuing algorithms as well, so that one VM cannot monopolize the shared network or disk bandwidth. Smart schedulers, they always try to prevent the problem entirely by keeping the risky, the bursty workloads further away from the latency sensitive services. So this was all about the noisy neighbor problem. I hope you got a basic idea about what the noisy neighbor problem is and how different cloud computing companies solve this problem. So I hope you like this video. Let me know what you think on this one, and as always, thanks for watching.